Assalamu alaikum everyone. Today we are going to conduct lecture number 25 of this course, Microprocessor and Assembly Language. And today we are going to deal with rotate instructions in our topic. So let's proceed to our topic. Okay, very first instruction we are going to cover is rotate left, ROL. It's mnemonic, and what is the meaning? Its meaning is rotating left, and the format it's very similar what we have learned in shift instructions. So ROL, rotate left. There will be an operand which is D operand, and that will be our destination register which is going to get rotated. And there is a field which is called count, and its purpose is almost similar what we have learned in shift instructions. So how this operation is performed, whatever the value which is given in the register or the D register, we have to shift it towards left, and the bit which is coming from the leftmost side will go back in the most significant or the right most significant position of the register. That is why this particular shift is known as rotation, because we are looping back the number which is coming out of the register from the other side. Okay, this last column indicates number of flags which can get effect from this instruction, and furthermore some flags which like OF flag is undefined, so it is also mentioned in certain conditions. Okay, second instruction we are going to cover is rotate right, and ROR is its mnemonic. The format is very similar what we have learned in the format of rotate left, so this format is also similar, rotate right D comma count. So what we are going to do, rotate D or the destination register towards right by the number of bits which is given in the count. That means if the count is 3, then we have to shift or we have to rotate the D register by 3 bits. If count is 4, then we have to shift the D register by 4 bits. So that's how it will be performing. And furthermore, the bit which is coming out from the rightmost side will going back to the loop or will be going back to the leftmost bit of the D register. In the likewise the previous instruction, we have also some flags which can get effect from this instruction, so these are mentioned in the last fourth column. Okay, let's proceed to the next slide. Okay, here we are going to discuss rotate, a different version of rotate instruction, and those are basically rotate left through carry and rotate right through carry. This C word is, or this C letter in the mnemonic indicates carry. So this time we are not only shifting or we are not only rotating our D or the destination register, this time we will be actually rotating the D destination register with the carry. So what is going to happen, the procedure will always will almost similar, but what is going to happen, in case of we are performing RCL, so left most significant bit which is coming out of the register will go to the carry, and the carry bit which is earlier stored in the carry flag will go into the rightmost position of D register. And similarly, if we are considering RCR, which is rotate right through carry, that means we have to rotate our D or the destination register equal to the amount of the count, but the rightmost bit which is coming out of the register will be going towards the carry flag, and the carry flag's previous value will be going to the loop back, and that will be going to the leftmost side of the D destination. And this thing will be clear will be much more clear in the next slide. So let's go to the next slide so that we can graphically observe the operation of these instructions. Okay, here we are going to explain the concept, and this is the concept, or this is the diagram. One can clearly see that this bit which is D naught bit, okay, and we are performing what we are performing rotate right. So this bit which is D naught bit is going to loop back and going inside D15. So that is the simple rotate right, and similarly rotate left, this D15 bit, right, and this is going to loop back to D0 position. So that's how this simple rotate left or rotate right command works. One can see that. And similarly, for example, if we are rotating towards left, so D0 will be shifting toward D1, D1 shifting will be onwards. This shift will go on unless this D14 is shifted toward D15 and D15 go out, which eventually come back to this D0 position. So that's how this function works. I hope this is clear. Let's proceed to the rotate left and right through carry. How that particular is different from this rotation. Okay, here we are going to consider rotate right and rotate left but through carry. So this is the D0 bit and we are performing rotate right. That means rotate right through carry. That means D15 will be switching towards what? D14. D14 will be moving onwards and onwards and onwards and onwards, and what will happen? D1 will come up here, and this D0 which is coming outside the flag, it will go to the carry flag. And remember, in this carry flag there will be certain value prior this operation, so that will be going to loop back and that will be coming here at this position, which is D15. So that is the concept of rotate right through carry. I hope this is clear. And in similar fashion, one can also understand the rotate left through carry. And in this particular diagram, one can clearly observe, so D0 will be shifting towards D1 and onwards. This procedure continues. D14 goes to D15 and D15 will be coming out of the register and going to this carry flag, and whatever the value inside this carry flag will be coming back for the looping back, and that will go to D0. So that is the procedure of rotate left through carry. I hope this explanation is clear. Let's consider their emulator examples. Okay, we are going to learn about rotate right instruction. So let's see what is going to happen. First of all, we need to have some value in certain register. Let's say we move a value, move tx comma 4568. Sorry, why it is not writing 4568 hex. So this value is stored in dx and we are going to rotate it by certain value. Let's decide certain count value. Let's say we use CL register as a count, so we store certain value. For example, we use a 3-bit rotation. Okay, 3-bit rotation, so that it will be 3 hex. And now we are going to rotate right. So dx is our destination register and CL is our count value. That is the format of this instruction. Let's proceed. Before we go and evaluate this program, okay, first we can check if there is any error. Let's emulate it. Okay, there is no error. So before we go and run step by step this program, let's consider the output manually. Okay, so we know that the value of dx is 4568 hex, and if we convert that value into binary, that will become 0100, 0101, 0110 and 1000. So that is the value, and we are going to shift or we are going to rotate it. So what is going to happen? These three value will be coming out of the register, so we can simply copy the other content, because that will be the content. Let me set it again. Yes, like this. So one can see one is coming here, 0 will be coming here. Okay, that's how it will be mentioning. I hope you can understand this rotation. This is 3-bit rotation, so I'm rotating 3 bits, right? So now these 3 bits are remaining, and what will be? These 3 bits will be coming here, right? So that will become 0, 0 and 0. Remember, we are shifting towards the right, so these will be coming back to the register. So that will be our new content, and if we convert it into hexadecimal, it will become 0, 8, A, and 110 means 13. 13 is basically D. So that will be our content in hexadecimal, in the new content or the output content. Let's comment it. Yes, here is a comment. Yes, let's see if this result is coming from this emulator or not. So single step. Okay, what is happened? See, 4568 is already here now. Okay, next CL is count 03. So we are going to rotate this command, and one can clearly see that 08 AD is in this register, in the DX register. I hope this rotation is clear to everyone. Okay, in this slide we are going to discuss rotate left instruction. So let's consider dummy data. Let's say we move the value, this time we use the BX register as destination register, so we can say that the value is 0FF0FCD. okay, this is the value I have loaded in BX register. So now let's consider our account, which is basically our C register. Let's say CL value is 02, so we will be shifting by 2 bits or rotating it by 2 bits. And now the rotation instruction, which is rotate left BX comma CL, which is our count. So let's do it manually. Okay, we can check it if there is an error. Let's press emulate. Okay, there was no error, the program is running successfully. Let's emulate first manually, and then we will be observing the emulator output. So value is 0FFCD. This 0 was just a prefix, so I will be just removing it. FF means 4 times 1, next F 4 times 1, C is 12, so 0, and D is 13, so 0 1. So that is the output, and we gonna shift it, or we gonna rotate it towards left. So this time these 2 bits will be coming back, or these 2 bits will be coming to the loop. Let's say what is going to happen, I'm just copying it, copy the content, right? I hope this is clear. And these 2 bits which is rotating, we will be copying in the last. So if we set it in 4 bits group, which is our nibble in this course, okay, and so one can see this is our rotated data by 2 bits. So if we convert it into hex, that will become F, that will become F, and that will become 3 and 7. So that will be our rotated information. So let's see if it is result is coming back in this expected output or not. So FFCD, which is loaded in the BX as we were expecting in this instruction. Next step 02 is loaded on the left in the count, and now we are rotating it. So this result FF37, I hope you can see that this register is rotated by 2 bits. I hope this explanation is clear to everyone. Okay, now we are going to explain you about rotate through carry, rotate left through carry, and let's see how we are going to do it. First of all, we know that it is related with carry, so let's open our flags register. CF is 1, one can clearly see it, it is already 1 here. So okay, so let's consider, let's say move dx comma 023534 hex. This is our value, and we are going to rotate it. So let's run it. Let's rotate, use our count, which is, let's say we are rotating by only 1 bit, okay, just to see if it is being rotated or not. And then we can do what, we can use our rotate instruction dx comma cl. Keep in mind that CF is high before this program execution. So let's emulate it. Okay, no, that was not high, so we have to make it. Okay, let's add 2 numbers to move ax comma f245. okay, sorry, 0 prefix should be used here, and that is the number. And we're gonna add ax comma, we are deliberately producing a carry, so we will be adding another hexadecimal number. So let's say we add f0 hex. So of course there will be a carry, as we know that f plus f, of course it will be exceeding the 16-bit limit, so there will be a carry flag in the result. And then ax will have certain value, and it will be rotated by rotated through carry. So let's say we are rotating it with we are deciding our count, so move cl comma, let's say we rotate it through just 0 1 hex, so we are just rotating by one count. And then we use rcl and ax comma 0, no sorry, cl. Okay, so that is our, so emulate it, no error, single step, f245 is loaded, another single step, so one can see e2 f45, which is the instruction, and furthermore this carry flag is high. So now we have a carry, so definitely there will be involvement of carry once we are going to see the rotation effect. And remember, if we haven't performed this addition, what could happen? Actually we didn't have any carry, so it won't affect anything. So that is why I wanted to show you the carry effect. So let's consider it now. Now the value is what? Let me do it manually first so that one can clearly see. We know that carry flag is equal to 1. Furthermore, AX register is equal to what? E245. So if we convert it into, okay, carry flag is one thing, and then E means 14, which is this one, 2 that would become 010, 4 that become 0100, 5 that becomes 0101, and now we will be rotating it through carry. So what is going to happen? C flag will be coming here, and this most significant bit to on the left side will be going towards this carry. So what is going to happen? This one will come up here, so C value is 1 again, and we will be copying the rest amount because we are rotating it. Okay, and what will be happening on this rightmost? This one, which was basically earlier what, which was basically carry value, it will come up here. So that is the result. So let's split it into 4 blocks. So that would be, there will be, okay, sorry, there will be a gap, and there will be a gap, and that's okay, that's okay now, sorry. So there will be, yes, I hope everything is settled. So what is happened? This one is shifted here in the carry flag, and this one value is rotated back over this position. So this is the result we are expecting in the output. So what is going to happen? C will become 1, and furthermore that is equal to what? C that is equal to 4, that is equal to 8, and that is equal to what? That is 1011, that is 11, which is B. So we are expecting this result. Let's single step. Look, C48B, it is here, and carry flag is 1. I hope this explanation is clear. Okay, we can further extend this discussion. How if we don't perform this addition, what is going to happen? Let's see. Okay, I'm just doing this calculation, but this time I'm not going to perform any addition, so there won't be any carry in advance. So let's see what is going to happen. I'm deleting it, right? So let's emulate this program. Okay, single step, f245 is loaded, another single step, cx is equal to 1, and now what we are going to do, we are going to run this rotate instruction, but before we must know that carry flag is 0. So if we do it manually, that will become C is equal to 0, or the carry flag is 0, and AX is equal to what? F245. So let's C equals to 0 is same thing, and F means 4 times 1, 2 means 0010, 4 means 0100, and 5 means 0101, right? So if we am going to rotate it towards left, and that one will be going towards this carry, so what is going to happen? C is equal to 1, because this one will be going towards this carry, and the remaining stuff will be getting just copied because it is shifted here. Okay, this is just normal shifting, or what you call rotation. So this most significant side is empty. What is going to happen? Whatever the last carry value, it will be coming up here. So this is our next value. So let's consider it. It is equal to what? E, right? It is equal to what? 0100, that means 4, and that will become 8, and that will become A. So that is our expected output. Let's consider the single step. Look, E4, 8A, and furthermore carry flag is high. So I hope you have understand the concept of rotating any register in 8086 through carry. So that's how rotation is performed through carry. Okay, now we are going to see rotation of any register through carry but towards right. So let's consider a number. Let's say we have moved CX. Let's say we have moved AX comma 2589 hex, and this time we add certain number in it, remember, just to show the carry. Okay, or we can ignore it. Okay, let's do this function without addition. So what can happen? We can do what? Move CL. Let's say we are going to shift it by 3 units this time, and this time we are going to rotate it right, RCR. So AX comma CL, what is going to happen? Let's emulate this program. Single step, 2589 is loaded, perfect. 03 is loaded, and now we are going to rotate it. Remember, we have to see the status of the carry flag as well. It is also 0 here. So let's perform it manually. C is equal to 0. What is going to happen? AX is equal to what? AX 2589. So if I convert it into binary, C is 0, AX is 2, 2 means 0110, sorry, 0010, 5 means 0101, 8 means 1000, 9 means 1001. Okay, so what is going to happen? We are going to shift it right towards right, so that these 2 bits will go out. Okay, so whatever this amount is going to get copy here. So if I arrange it, it will be like this, right? And now this thing is common. What is going to happen? Okay, sorry, where is it? Yes, here. Yeah, so this 0 will come up here. Of course, this is just one shift, and that one, right, this most significant one will go to what? They'll go to this position. But that's here our value is not complete, right? Furthermore, it will shift again. So what is going to happen? The C value, which is 1 here, will come up here, and this 0 will go to carry. I hope this rotation is clear. This time we are shifting it by 2 unit. You can do it step by step, and you will understand it. I hope this position is clear. So what this will be 8, and this would be what? This would be 9, and this would be what? 6, and that would be 2. So this is our expected result, with carry would be 0. So let's see if it is coming or not. No, it's not coming. Why? What mistake we have done? Okay, we are missing something. 2589, 2589, that's okay. So 01 here, 00 is here, 10 is here, 01 is here, 01 is here, 10 is here. Okay, 00, Okay, mistake is here. I'm not rotating it by 2 units. That was 3. I'm sorry, that there's a mistake. Count was mistakenly 3, so we have to rotate it by 3. So I'm just gonna comment it because this will be error if I don't comment it. Emulate 2589 and our expected output is 8962. I hope this is clear now. Sorry, there was a mistake. 02 was mistakenly typed as 03, so that was a mistake. Otherwise everything is okay. So I hope this rotation is also clear in your mind. Okay, that's it from this lecture. I hope today we have learned clearly everything about rotation instructions, whether we are going to rotate any register without any carry flag or through carry flag. Those rotations are clear to you, and if you have any query, please note them down and we will try to resolve them in online session. Thank you so much.